Have you ever looked up and seen a plane soaring overhead, leaving a white trail behind it? It's a sight that never fails to inspire wonder, reminding us just how far human ingenuity has taken us. Those streaks in the sky are more than just lines. They're evidence of a remarkable technology at work. That's the magic of the jet engine, the heart of modern flight. This powerful machine is what makes it possible for massive airplanes to lift off the ground and travel at incredible speeds, carrying people and cargo across the globe. By turning air and fuel into pure speed, jet engines let us cross entire continents and even oceans in just a matter of hours. What once took weeks by ship can now be done in a single day, shrinking our world and connecting distant places like never before. But what's the secret behind this power? It all comes down to a simple principle from physics, Newton's third law. For every action, there's an equal and opposite reaction. This law is the foundation of how jet engines work. Imagine you're standing on a skateboard and you throw a ball forward. Instantly, you roll backward. That's Newton's third law in action. And it's the same principle that propels a jet. A jet engine does something similar, but instead of a ball, it blasts out hot air at high speed from the back of the engine. This powerful blast creates thrust, the force that pushes the entire airplane forward, allowing it to accelerate down the runway and soar into the sky. Inside the engine, a fascinating process unfolds in four main steps: suck, squeeze, bang, and blow. First, the engine pulls in huge amounts of air at the front. Next, it compresses this air, mixes it with fuel, and then ignites the mixture in a powerful explosion. The resulting hot gases are blasted out the back of the engine at incredible speed, creating that all-important thrust. Each of these steps happens in a rapid, continuous cycle, with the engine working tirelessly to keep the plane moving forward through the air. Next, let's take a closer look at how this force of thrust actually moves a plane and keeps it flying high above the clouds. Thrust is what moves the airplane forward, overcoming the force of drag and propelling it down the runway. Without thrust, an airplane would simply sit still, unable to break free from the grip of gravity and friction. It's the essential force that gets a plane rolling, accelerating, and eventually soaring into the sky. To picture thrust, think of a balloon flying around when you let it go. The air rushing out the back pushes the balloon forward in a wild, unpredictable path. That's thrust in its simplest form, a burst of energy sending something in the opposite direction. A jet engine is a controlled, superpowered version of that balloon. Instead of air escaping randomly, everything is precisely engineered to maximize forward motion. The engine takes in air, compresses it, mixes it with fuel, and ignites it, creating a powerful stream of exhaust. The giant fan at the front pulls in tons of air every minute, acting like a massive vacuum cleaner. This fan is so powerful that it can move more air in a few seconds than you could in an entire day. Some of this air goes into the engine core where it's mixed with fuel and burned, but most of it, called bypass air, is accelerated around the outside of the engine. This bypass air is crucial for modern jet engines, making them quieter and more efficient. This bypass air creates much of the engine's thrust, like a high-tech leaf blower pushing you across ice. Imagine standing on a frozen pond and someone points a giant leaf blower at your back. You'd slide forward fast. The bigger and faster the fan, the more thrust you get. That's why modern jet engines have such enormous fans. They're designed to move as much air as possible as quickly as possible. Meanwhile, the engine's core heats a smaller amount of air, making it even faster and more energetic. This superheated air blasts out the back, adding to the total thrust. Together, these two streams of air, one cool and massive, the other hot and fast, are blasted backward, generating the immense force needed for flight. It's a powerful combination that makes modern air travel possible. It's a team effort between cold and hot air, each playing a vital role in pushing the airplane forward with incredible force and efficiency. That's how hundreds of tons of metal and people get off the ground and into the sky, all thanks to the remarkable science of thrust and the engineering marvels that harness it. After the fan pulls in air, a remarkable transformation begins inside the jet engine. The air, which started out at normal atmospheric pressure, is about to undergo an intense journey. The compressor, a series of spinning blades and stationary vanes, grabs hold of this incoming air and squeezes it tight, forcing it into a much smaller space. Rows upon rows of rapidly spinning blades work together, each stage compressing the air a little more, until the pressure and temperature rise dramatically. This process is both powerful and precise, engineered to maximize efficiency. It's a lot like pumping up a bike tire. The more you squeeze, the hotter it gets. The energy you put in doesn't just make the air denser, it also makes it much warmer. In fact, the compressor packs the air to over 40 times its original pressure, creating an environment where the air is dense and full of potential. Why go to all this trouble? Compressed air is packed with potential energy, like a coiled spring, ready to be unleashed in the next stage of the engine's cycle. This step is absolutely crucial. It allows the fuel to burn much hotter and more efficiently, releasing far more energy than it could at normal pressure. Without this compression, the engine simply wouldn't have enough power to generate the massive thrust needed to lift an aircraft into the sky. The compressor does use a lot of energy, but it's a necessary investment. It sets the stage for the next explosive phase, where all that stored energy is released in a controlled burn. Now, with the air tightly packed and primed, let's add the firepower and see what happens next. Here comes the bang. The compressed air enters the combustion chamber. Fuel injectors spray a fine mist of jet fuel, mixing with the hot air. An igniter sparks and a continuous controlled burn begins. The temperature soars, causing the air to expand rapidly. This expansion turns the air into a high-speed, high-energy gas. The combustion chamber is built to handle this intense heat and keep the burn steady. The only way for the gas to escape is out the back, creating a powerful force. This is the heart of the engine's power. Finally, the blow, the exhaust. The super hot gas rushes through the turbine, spinning it like a pinwheel. The turbine powers the compressor and fan, creating a self-sustaining loop. After giving up some energy, the gas rockets out the nozzle at maximum speed. Newton's third law kicks in, blasting gas backward pushes the plane forward. The cycle repeats, suck, squeeze, bang, blow, turning air and fuel into thrust. Every part works in harmony, making flight possible. From intake to exhaust, it's a symphony of physics and engineering. That's the marvel of the jet engine. Science really does make us fly.